So we are here together learning engineering mathematics for GATE examination, and so everybody is joining. We'll see what is engineering mathematics, what is GATE, and what are the strategies we should follow so that we can score really well. Good morning, Siddesh. How are you? So meanwhile everybody is joining, we can have a small introduction also. Let's see how many of you are from third year, how many of you are from fourth year, and the students have done and finished your engineering so that they may be attempting for 21 this year. For all the people who have joined, you can also share the link with other people, with other friends, so that we can learn the subject together. Hello Ayush. Hello Piyush. How are you? Okay, that's great. Your first day. So let's start with engineering mathematics. That will be really exciting if you are starting with engineering mathematics. Good morning, everyone. So now that everybody is joining, I'll also request you to share the link with your other friends so that we can learn the subject together. So let's see what is GATE first of all. Why are we here and why do you want to attempt for the GATE? Very obviously, we know that some of you have got into good college, some of you may have not got into good college, or some of you have already passed and not got into good jobs or something like that. So GATE is a platform where everybody can attempt and have a same platform where the evaluation is done on the same basis, and then you can directly get a good score and get into some of the good companies while after cracking your interview. Yes. So Pius is very excited. That's really nice. That's really nice. So let's see what is engineering mathematics in this GATE examination. So overall, in this GATE examination of the 100 marks subject, which we have about 65 questions, you may expect around 5 single marks and 5 2 marks of questions, which will overall make up to 12 to 15 marks in the overall subject. So that's a good weightage. And while you start engineering mathematics, something which comes into your mind is like how do you start, because this is something you have covered for 3 4 or maybe 5 semesters. Like electrical people have this for 5 semesters. So where to start, what to start, you don't get how to do this. So I'll tell you, like obviously the subject is not easy, but definitely you can score well if you put your efforts in the right direction, make a strategic movement, and then keep practicing. So what is important is you need to practice more and more. Yes. Hello Lalit. Good morning. Good morning. So introducing about let's have a small introduction about myself also. I'm Rohit Sahu, and I have been into this GATE teaching for past 4 years, more than 4 years, and I've also handled more than 50 batches and engaged with more than engaged with thousands of students. And some of the in gate ranks in my journey has been like a rank under 1,000, a rank under 500, and some of the best ranks were around 200 also. So all I want to say is, in this subject, if you put your right effort, right direction, you can score well. And this is something which gets you into the run of good rank. Because if you drop this subject, you just forget about like clearing with a good rank. You can just qualify somehow, but you can never get a good rank if you drop this subject. So more about the subject, I'll say while you have to practice, I'll suggest that you should go for with the previous year questions. Like you'll get around 10 sets of paper like every year, like engineering, mechanical, civil, every branch, and almost all the branches have 10 questions. So you can see that every year you can have hundreds of questions, and then you can manage, like in the past 10 15 years, you can manage to have some question collection of 1,000 or maybe 1,500. So that's a good number. And apart from that, we'll try to focus on the session, the mock test and everything. Right. So you must be knowing, as you have gone through the package, or you have gone through the app, or you have if you have gone through the link for the website also, you'll see that the package is containing almost 400 or more than 400 hours of recorded lectures, more than 20 mock tests. So mock test is very important, and apart from that, you also have 100 of subject tests. So that is also very important. And apart from all these recorded classes, you have live session, live doubt session for all the subjects, like 20, more than 20 hours of live session of all the subjects. Even for our engineering mathematics, we are going to have 25, around 25 hours of live doubt sessions where we can interact, we can know and understand the frequency what you are getting at now. Right. Hello, Nasreen. So let's see. Meanwhile, we can also see the syllabus. Overall, the syllabus is same for all the branches, but and I won't get into the syllabus part. But there are some of the topics I like to say that, like civil computer science. Computer science is a subject which has two parts. Like discrete is also there, linear algebra, and all these subjects are also there. So there are many of the topic we'll be discussing may not be in your syllabus. So keep this in mind. Apart from that, civil is something which has a major difference in the syllabus. Like they don't have complex analysis, but they have partial differential equations. So they stress more on PDE, and they don't have anything related to the complex analysis, right? Apart from that, moreover the syllabus remains same. So that will be good. So I think that is enough for the subject, and then we can actually start. Apart from that, this 10 marks of 10 to 15 marks has like 6 units. So some of the important topics are linear algebra, calculus, probability. These are the important topics. Of course, you get questions from other topics also, like complex has really good questions if you have an analytic understanding. This is very important. Apart from learning the formulas, apart from knowing how to solve, and an analytic understanding of the subject is very important, because they'll always come up with something new in the question. So you need to get that catch. Once you get the catch, you can solve this question in the next 2 lines, maybe 3 lines. So that is going to really help you, because you don't have to solve the questions conventionally in objective examinations, because that will also take your time, and maybe you are going wrong somewhere, right? So there's definitely a catch. Good morning, Asutosh. So let's start. Let's start with the subject. Right. So we'll start with the first unit, which is linear algebra. And this in the subject, linear algebra, we'll start with the topic matrix. We'll discuss the matrix today. So let's see what is this. In the subject, my suggestion is that this subject has many small concepts, or many small theories or properties which are directly asked in the examination, very directly asked in the examination. So you have to make sure you remember all the properties, all the simple formulas and expressions, like basic definitions are also asked directly for 1 marks. So you see, you click the answer and you move, you are definitely going to score 1 marks for that, right? So let's see. So we'll start with the topic linear algebra, and that is matrix. So what is matrix? We all know what is matrix. We have seen in this higher secondary also. It is a rectangular array, right? So this rectangular array can be of certain size. What is the size here? This is m cross n. So this m is nothing but the row, and this is the column, right? This is the column. So overall, it will have, like, these are all rows, like this is row 1, this is row 2, so on, and then last we have row m. Similarly, we have column 1, column 2, and so on. So overall, the dimension, the size we say is m cross n. And this m cross n is going to have all these elements a11, a12, a13, and so on. So any element of this matrix A is denoted by aij, and this ij is, I is the ith row and j is the jth column. And once you have I equal to j, once you have I is equal to j, you can see like a11, a22, a33, and so on. These are all the elements for which the number of row and number of column positions are all same, and these are actually known as diagonal element. This is known as diagonal element, right? Other than that, when I is not equal to j, we say it is off diagonal element, right? You must be getting the links for the registration. You must be getting the link for apps, so you should visit it afterwards, and so that you can know more about the subject. You can know more about the package you're going to get, right? And obviously, you can also avail the offers currently going. So apart from that, these are the diagonal and off diagonal elements. So like A21, A31, these are off diagonal elements. And if you go down or below the diagonal elements, you'll see like A21, A31, you can simply see that you are increasing the number of row, keeping the number of column same. So the lower of diagonal element is where I is greater than j. This is lower of diagonal element, right? So this is I greater than j is lower of diagonal elements, whereas when I is less than j, these all elements is where I is less than j. This is where you have upper of diagonal element, right? So this is about your matrix, how it is designed, what are the elements, what is diagonal elements, what are off diagonal elements. Apart from this, we need to know about the types of matrices. So let's start with the first one. We can actually start with the rectangular. Rectangular matrix is something where m and n, that is the number of row and the number of column, may or may not be same. So that is okay. Like you can see, this is something having 2 number of rows and 3 number of columns. So this is 2 cross 3. This 2 cross 3 matrix is something a rectangular because 2 and 3 are different. Now when m and n are same, that is the number of rows and columns are same, this is like 2 cross 2. So this is a square matrix. This is a 3 cross 3. You'll also get to see that there is a matrix of order 3. So matrix of order 3 means that, good morning issue. So matrix of order 3 means that you have 3 cross 3, or the number of rows and columns are 3, right? So this is how you have to see as a square matrix, as a rectangular matrix, right? Enough about this. Now let's see the other two matrices. The third one is diagonal matrix. What do you mean by diagonal matrix? Diagonal matrix is a square matrix. So it is a subset of square matrix, and this square matrix is having all its off diagonal elements to be 0. So for everyone, you try to focus on the concepts here. You can easily write down the notes afterwards also. This recording will be available. So let's try to understand so that we can focus more on questions rather than just writing it like your conventional way methods, right? So we'll try to focus on the concept, and then we can do more and more questions. So this diagonal matrix is a square matrix where off diagonal elements are 0. You can clearly see these elements are off diagonal elements which are 0, whereas 1, 7 and -4 are all diagonal elements. It may be 0 and it may not be 0, but definitely off diagonal elements have to be 0, right? So now this diagonal element a1, 7 and -4, that makes it a third order matrix. Obviously it is a square matrix, and it can also be written as A is equal to diag 1, 7 and -4. This clearly means that it is a square matrix with the diagonal element A11 as 1, A22 as 7 and A33 as -4, right? Then comes your scalar matrix. So this is a subset of diagonal matrix. It is a subset of diagonal matrix. And this means that all the diagonal elements have to be same. All the diagonal elements have to be same, right? So you can see A11, A22, A33 are all 2, right? You can clearly see that this is a square matrix, diagonal matrix, and then a scalar matrix. Apart from this, next is very important one, which is identity matrix. Identity matrix is something which has a diagonal elements to be 1, and it is a subset of scalar matrix, right? So it is subset of scalar matrix. That means the off diagonal elements have to be 0 and diagonal elements have to be same. Now the special case is that all the diagonal elements have to be 1. So A11, A22, A33 are all 1, whereas other elements are 0, right? So this is your identity matrix. It is denoted as I. And by IN, we mean that the matrix is of order n. So like for this example, this is matrix of order 3. So we'll write it as I3, right? Some of the properties which is very important for this identity matrix is A into identity gives you A, or I into A gives you A. That means this is a multiplicative identity. Multiplicative identity. That means when you multiply a matrix with I or identity, you'll get the matrix itself, right? So what if A is nothing but the identity matrix? Then I into I should give you I. So that means I square is equal to I. And when you multiply I square with I, that again becomes I square, and which is I. So that means I to the power n will always remain I. I to the power n always remains I, right? So after that, you need to know that I is itself inverse. We'll discuss inverse afterwards, but meanwhile, hello Manchi. So meanwhile, I'll tell you what is inverse. A very basic about the inverse is when you multiply a matrix with another matrix and you get identity matrix, then you say that B is the inverse of A, right? So similarly, when you multiply I with I, you get I. That means I is nothing but itself, its own inverse, right? Other than that, you'll also come across the determinant. The determinant of identity matrix is always 1, right? So these are some of the important properties of identity matrix. And I'm telling you again, all these small properties and concepts or the knowledge of the basic things are all direct 1 marks question. So you cannot skip this, right? Other than that, null matrix is very simple. All the elements have to be 0. All the elements may be rectangular matrix or square matrix, anything. It can be a rectangular matrix, but all the elements have to be 0. And this A plus O 0 or null matrix gives you A. This is like identity of addition. That is like when you add a null matrix to a matrix, you get the matrix itself. So this is additive identity. Apart from that, we'll also see this upper triangular and lower triangular, more important for, like, obviously important for everybody, all the branches, but more important, I'll say the CS people should also focus. I hope there are many CS people also here. So you'll also come across LU decomposition in your syllabus, and for this you should know what is upper triangular and what is lower triangle, right? Hi Risham. So if you want, you can also write the branch you are from along with good morning. So the way, like Rishabh and Ishu and everybody, whatever greeting you are coming up with, please also mention your branches which you belong to, right? So that will be good for me to know. So let's see what is upper triangular matrix. Upper triangular matrix is something which has lower of diagonal elements 0. What is this? This is lower of diagonal elements. We have already seen where I is greater than J, like we have already written here. So for I greater than J, for a square matrix, you'll get the terms to be 0, right? So this is how you can see that this is a upper triangular denoted as U, and this is lower triangular denoted as L, where the upper of diagonal elements are 0. That is where I is less than J, right? These are the elements where it should be 0, right? So what is row, what is column matrix? Row matrix means there is only one single row. So you can see this is row 1. There are 4 columns, right? Good morning, Abhinav. Please mention your branch or stream which you belong along with your greeting, right? So it will be good to know my branch is mechanical, right? Abhinav, good, Abhinav. So let's see, you are going to get direct questions. I'll talk about civil and mechanical have very conventional and direct questions some of the time, many times I'll say. So it's good if you go through the topics, the concept and the questions we discuss in the class. That will be like enough to score you, get you 10 marks or more than that in your gate examination, right? Good morning, Piyush. Civil department, right? Good, great. So you all are from core branches, right? Hemlata, good morning. So let's talk about column matrix also. Column matrix means there is single column, right? Apart from that, you may have n numbers of m numbers of. So this is 4 cross 1, which means there is only one column. This is 1 cross 4, which means there is only one row. One column, one row, right? Good morning, Baba. Where are you from actually? I have seen this name first time. Other than that, these three are okay, not so important, but let's have a small knowledge so you can just see what is it. Indipotent, nilpotent, and everything. Not so important, but it's okay. You should have a small knowledge on this. So after this, we should start and we should go for the operations. Some of the basic operations involved in matrices, and then we can directly move to the higher concepts, right? So let's see what is equality. When you compare two numbers, you just compare the magnitude and the sign, right? But when it is about the matrices, you need to see that the matrices have to be of the same size. So if one of the matrix is 2 cross 3, the other matrix should also be of same size 2 cross 3. It cannot be of other dimension. Once it is of other dimension, it cannot be compared and it cannot be done. Many other operations cannot be done, like addition cannot be done, subtraction cannot be done, and likewise. And once the dimension of both the matrices are same, the next important thing is to compare each of the element. Each of the element. That means, just see this. If you have A, B, C, D, and the other one is E, F, G, H, then the corresponding element, like this is A11, this is B11, this is A21, this is B21. So the corresponding elements needs to be compared. So if I say A and B are same, then A should be equal to E, C should be equal to G, and so on, right? You getting the point? So apart from that, so this is about equality, which is required to know once you are getting into the property operations of addition and subtraction. Let's see what is addition now. Addition is about adding the matrix, and for that it has to be of the same dimension. You cannot have two different dimensions and then you can add it. No, they have to be of the same dimension and the corresponding element can only be added. Like A11 should be added to B11, A22 should be added to B22, and likewise. Just for an example, let's see this. What is the dimension of this matrix? Let's say this is A plus B. So what is the dimension? Can you tell me the dimension? It is 2 cross 3, and this is also 2 cross 3. And then while adding, you need to have the you can say the elements, exact elements to be added. Like 1 should be added to minus 3, so 1 and minus 3 are added, 0 and 2 are added, 6 and 1 are added, 3 and 4 are added, minus 2 and 0 are added, and so on, right? Do you see that? Hello, Sajay Vinay, hello. Please mention your branch along with the greeting also, right? So you can see you're adding the corresponding element. So 1 is added to minus 3, 0 is added to 2, and after that the operation results in the same dimension of matrix. Do you see that this is also 2 cross 3? Yes, this is also 2 cross 3. That means it has to be of the same dimension. And 1 minus 3 will give you minus 2, 0 plus 2 gives you 2, 6 plus 1 gives you 7, 3 plus 4 gives you 7, minus 2 plus 0 gives you minus 2, 5 plus 6 gives you 11, right? No doubt, right? You have to add all the elements, corresponding elements of both the matrices. The condition is they have to be of the same dimension, right? Now what is the property? Property says A plus B can be compared to B plus A. That means it is commutative. A plus B is equal to B plus A, so it is commutative. And yes, Rishabh, I have seen your branch, right? And it is associative. That means whether you add A plus B together and then C, or you add A with B plus C, you'll get the same. That means it is associative. Next is additive identity. You have already seen that. Additive inverse, that is also okay. That is also fine. No problem with that. So Other than that, this next is subtraction. We'll try to do the same operation with the same matrices we have discussed in the previous case. This is A and this is minus B. Again, what is important? Both the matrices should be of the, yes, Piyush, correctly said, 2 plus 3, 2 cross 3 should be added with 2 cross 3 and the result will be 2 cross 3. Exactly. Similarly, the same operation is applied for subtraction, then also you'll get the same dimension. So if you are subtracting A and B, then you'll see it has to be of the same dimension and the result is also same dimension, 2 cross 3, 2 cross 3 and 2 cross 3, right? What you have to do is subtract the elements of B with the elements of A at the corresponding position. That is, at 1 1 position you subtract 1 1, A 1 1 minus, so that this is like A 1 1 minus B 1 1, A 1 2, then B12 and like that. So you have to subtract the corresponding elements. It is neither commutative nor associative. So A minus B cannot be written as B minus A. No. And not associative also. So this is done. Let's talk about the multiplication, then we can go for the questions. We'll definitely see the questions after this. So let's see, there are two types of multiplication. The one is scalar multiplication. Scalar multiplication is like multiplying with a constant, with a real or complex number, like 5. Like in this example, we have seen 5 times of the matrix. This is 5 times of the matrix A. So what is it? For scalar multiplication, you need to multiply every element with that scalar. So this 2 cross 3 has almost overall 6 elements. Every element should be multiplied with 5, right? So 2 into 5, 2 into 5 into 0, 5 into 6, 5 into 0, 5 into minus 2 and 5 into 4. So what do you get? We get 10, 0, 30, 0, minus 10 and 20, right? Obviously it won't change the dimension, right? Other than that, now that you have this matrix 5A, what more you can do? In the similar fashion, you can take out something common, and that is what we have done in the next step. I have taken out 10 common from the matrix. So once you are taking common, what will you do? You will take out this common from each of the elements. Like from 10, if you take common, it will be 1. From 0, it will be 0. From 30, taking out 10 common will become 3. From 20, it becomes 2. From minus 10, it becomes minus 1. Clear? Clear this up? Is it okay? So you see that in the manner you can multiply is the same manner you can take out something common, and that is what we have written in the property, that this is, it can be distributed, it can be associated and all this, right? So these are the properties, not much required, but you should know because it will like there are some of the basic operations in which you'll require this. So next one is matrix multiplication. I'll say it is very important. If you don't know this, there are a lot of things which you'll miss. So make sure you focus on this. First thing is, for this matrix multiplication, the dimension. Let's say this is A multiplied with B to give you C. Then the number of column of the first matrix should be same as the number of rows of the second matrix. So let's say it is M cross N, then this should be N cross, let's say, some other L. Getting? Yes, Rishabh. So you're getting it, right? So that means the number of column of the first matrix should be same as the number of row of the second matrix. And then what you get is the result, the product is going to be M cross L. This is the dimension you'll get for the multiplication. Clear? If the number of rows, number of columns of the second and the number of rows of the first, the second matrix is not same, you cannot multiply. Multiplication is invalid, it cannot be done. Clear? So let's see, the example says, this is, you can see this is 2 cross 3 and this is 3 cross 2. So do you see that 3 and 3 are all same? Now is the moment when you can multiply, right? Correct, Piyush. So what will be the dimension of the matrix result? This is 2 and this outer 2, right? Inner numbers are same and outer number will give you the result. So the result is going to have the dimension 2 cross 2, right? How to multiply? We'll see that also. But what is important is dimension also, right? You will get direct questions or dimensions. Direct question on dimension, 1 marks question. Trust me, right? So let's see. So how to multiply this? This is your matrix A, this is your matrix B. And now you also know that the dimension is going to be 2 cross 2. We have already seen this, right? So now how to multiply? When you are choosing for the element C11, when you are making C11, you need to multiply the first row of matrix A with the first column of matrix B. First row of matrix A and first column of matrix B. So that is 1, 2 and 3 should be multiplied with 0, 2 and minus 1. Do you see this? 1 into 0, 2 into 2, 3 into minus 1, right? So what to do with for C21? Can you tell me about C21? Correct, Rishabh. Correct, Piyush. Piyush, right. Correct. Correct. 2 cross 2. You will directly get the questions. 1 marks question on this. Trust me. So it is very interesting. So C21, let's talk about C21. What do you have to do? It should be second row of A matrix multiplied with first column of B matrix. You getting it? Second row of A matrix multiplied with the first column of B matrix. Do you see this? This is your 2, 1. So this minus 204 has to be multiplied with 0, 2 and minus 1. And then you can obviously add or subtract whatever is required, and then you will get the result as 1, 2, minus 4 and minus 6. The properties are equally important. I'm sure you're getting it. The properties are going to be equally important. Correct. Correct. So let's talk about the property. The first property is it is not commutative. A into B is not equal to B into A. In fact, it may not be feasible also. Some of the time it may not be feasible. Like in our case only, instead of AB, what if you do BA? It will become, the dimensions are 3, although in this case you will get the product. 3 cross 2 into 2 cross 3. You will get 3 cross 3 as your output. Definitely you cannot compare this 2 cross 2 result with the 3 cross 3 result. So it may not be equal also. So it is not commutative, but it is associative. Whether you multiply BC first and then A, or you multiply AB first and then C, you'll still get the same result, that this is associative, right? Of course, this is distributive. It is distributive also. What about other three? These three are important. A into B is equal to 0 does not imply that the matrix is 0, whether A is 0, B is 0 or BA is not 0. We cannot conclude anything like that. If product of two matrices is 0, it can be non-zero vectors also, right? It can be non-zero vectors, and it may give, still it may give a null vector or all the elements to be 0, right? Second is, if AB and AC are equal, it implies B and C are equal only if determinant of A is not equal to 0. We'll see and we'll learn how to find the determinant. But meanwhile, only if determinant of A is not equal to 0, then only B and C are going to be same, right? And the next one is, the last one is diagonal. So two diagonal matrix, let's say A, B, C, and diagonal matrix D, E, F, then the product can be directly the multiple of the diagonal elements. Like A11 should be multiplied with B11, A22 should be multiplied with B22, and A33 should be multiplied with B33, right? You'll get the same result. Hi Rishabh. Rishabh, I am from Ranchi, Jharkhand. Where are you from? So for diagonal matrix, what you need to do is directly multiply the diagonal elements, and that will give you the result. कुछ भी और करने की जरूरत नहीं. Correct? So this is about addition, subtraction, multiplication, scalar multiplication, and your matrix multiplication. Now let's move to the questions. Let's see some of the questions related to this. You'll see how interesting the questions are. Let's see the first question. Everyone, let's see the first question. It says, Which of the following matrices are guaranteed to equal A plus B whole square? Correct? A plus B whole square. So what is A plus B whole square? It is A plus B into A plus B. This is very simple. May it be matrix or may it be a scalar quantity. It has to be A plus B into A plus B. That is what we know about A plus B square. Now, yes, try finding the answer. Which one of the following matrices guaranteed to equal A plus B whole square? Right? So once you start with A into A, you will get A into A, then A into B, then B into A, and then B into B. This is what we are going to get, right? Now, anywhere, is it going to be equal to the first option? This A into A gives A square. Yes. This is AB, this is BA, and this is B square. Option 1. Option 1 is the wrong answer. I'll tell you why. Option 1 is the one which is not going to be the answer. Why? Because right now, just now we have seen that multiplication is not commutative. That means A into B is not equal to B into A. So A into B is not going to be equal to B into A. That means we cannot put this together as 2AB. This is going to be wrong. You getting my point? This is not 2AB. This is not going to be 2AB, right? So this option is wrong. What about the second option? This gives you A square, then A into B, then B into A, and then B into B, that is B square. So do you see that these two are same? Yes. So this one is right. Second one is right. What about the third one? Why the third one is not going to be there? You have seen that addition is commutative. A plus B is equal to B plus A, right? Piyush, right? You know this, right? So that means even for this product, A plus B into B plus A, you'll get AB, you'll get A square, then B into B is B square, and then B into A is BA. You're getting the same thing. This option is also giving you the same result, right? So this is also right. This is also right. Now let's move to the next last option. A square plus AB plus B square. Very directly the expansion we have seen. The expansion we have seen. That means except option 1, all three options are right. All three last three options are right. So I'll say except option 1, all three are right. All three are right. Getting my point? All three last three options are equal to A plus B whole square. And trust me, you have a direct question very similar to this in your GATE examination. I don't remember the branch. I think it was mechanical or electrical. It was a very direct question on the same expansion, and you had to use the property that the product of matrices are not commutative. That's it. This property, not commutative. This is the result. Clear? Let's move to the next question. Fine. True, false. You have 4 options. You have to find true, false. Try. True, false. It says if A square is defined, then A is necessarily a square. Square in the sense square matrix. Is it true or false? Let's talk about option A. Let's say this option A, that A matrix is M cross N, right? Now, if A square is possible, when is this A square possible? That means A into A should be possible. That means M cross N should be multiplied with another matrix of m cross n. And you know that the column of your first matrix should be same as the rows of your second matrix. That means n and m are supposed to be same. N and m are supposed to be same. So m is equal to n, which makes this matrix to be a square matrix. It is a square matrix now. So option A is true. Option A is true. So I'll say this is right. What about other options? What about other options? A, B and B, A are defined, then A and B are square. Is it true? Just check your last example we have seen. We said that A is 2 cross 3 and B is 3 cross 2. Was AB feasible? Yes. Was BA feasible? Yes. What was the dimension of AB? The dimension of AB was the outer one, which is 2 cross 2, and dimension of BA, which was 3 cross 3. Why? Just reverse the order. This is like 3 cross 2 into 2 cross 3. So this gives you 3 cross 3 and this gives you 2 cross 2. So do you see that both AB and BA are defined, but they are not square matrix. They are rectangle matrix. 2 into 3 and 3 into 2. This is 2, right? So they are rectangle matrix. So B option is wrong. B is not a right option, right? So this was about B. What about C? AB and BA are defined, then AB and BA are square. You can already you can see it here. AB is a square matrix 2 cross 2. BA is also a square matrix 3 cross 3. So C option is right. What about the D option? AB is equal to B. We have seen the property multiplicative identity, which said A into I gives you A, right? Multiplicative identity. So if you compare these two, A into B gives you B, then A should be equal to I. Now if you have a confusion that this was AB, this is AI, then I have also mentioned that I into A is also B, sorry, A, right? These are the concepts we have learned. This is not related to the question. This is what we have learned for the identity matrix. Multiplication of any identity matrix with a matrix gives you the same matrix. So this was the concept. Don't compare it with the options and data informed. So AB is equal to B gives you A is equal to I. So this is option D. That means D is also true. So only B is false. B is wrong and the other options are all true. Is it clear? Is it clear? Yes. I'm giving 2 minutes for the next question, or I'll say I'll give you 1 minute, not more than that. 1 minute is enough. 1 minute for this question. You all can give me the answer. 1 minute. I won't solve this. I'll tell you the answer after 1 minute, right? And then we can switch to next question, which is really important. Yes, Piyush, Rishabh, everyone. What is the answer? Sajja Vinay, Bava, Ishu, Lalit, Siddesh, Ayush, everyone. What is the answer of this question? It is very simple. You'll get A equal to C. Correct. I'll tell you the, I'll just give you a hint that you have to use the associative property. Associative property of multiplication. That's it. Correct, Piyush. Correct. Let's see this interesting question. This is really interesting. And you have a very good and analytic question on this from your gate examination also. It says matrix A is n cross n, B is n cross p. Then the number of multiplication operation and the addition operation needed to calculate the matrix AB is how much? Clear? Is how much? Let's see. So let's say that you have this M cross N matrix and the next one is N cross P matrix. So the result is going to be M cross P, M cross P. This is the result you'll get. Now my point is you're going to have M cross P. That means these number of question is not clear. The question is if A is n cross n, the dimension, and B is n cross P, the dimension, number of multiplication required to find the result AB. So that is when you find the multiplication of matrix A with multiplication of matrix B, how many times you have to do the multiplication and how many times you will have to do the addition. Is it clear now? How many times you have to do the multiplication and addition both. Clear? Now, let's see. So if you have this m cross n, you'll have n number of columns, and n cross p, then you'll have n number of rows, right? And you know that for the first row, first element, what will you do? You will pick this row 1 and multiply with the corresponding element of column 1 of the second matrix, right? That means you will take these n items, n elements, and multiply with these n elements, right? Like A11 multiplied with B11, A12 multiplied with B21, and so on. So that means you will have to do such how many numbers of multiplication? N number. I'll write it here. N number of multiplication. Right? You'll have to multiply every element of row 1 with the corresponding elements of the column 1. So there are n elements, n number of columns in the first row. So you have n number of elements. Similarly, in the first column, you will have n number of elements. This is the number of rows. So that means for every element, you are going to do n number of multiplications. And then all such terms you will be adding, right? For example, let's see. It is 2 cross 3 plus 3 cross 1 plus 4 cross 2, suppose. So what you are doing is one multiplication, second multiplication, third multiplication. And how many additions you are doing? 1 and 2, 2 and 3. So this is again n number of addition. Right? That means you have such n number of multiplications and n number of additions also. Now, how many such elements you have to find for the matrix C? You have to find m cross p number of elements. That means, like in the previous case when you were doing the multiplication, you'll see that all such number of elements you'll have to find. This element, this element, this element, so on. So how many elements do you have for m cross p? You have m cross p number of elements. These are the number of elements. And for every element, to find every element, you are doing n number of multiplications and n number of additions, right? This means that you'll have to multiply it with n. So the overall multiplication and overall addition you are going to do is MNP, MNP. Clear? MNP and MNP. So C is the answer. Number of multiplication required is MNP. Number of addition required is also MNP. Clear? Clear? Now that the previous question is clear, you should try solving this question. And of course, if you have a problem, you can ask me. You have 4 matrices, and you have to do the operation A1 into A2 into A3 into A4. So this is what you have to do here. So how many multiplications? Now you got the number of multiplication. What do you mean by number of multiplication? Is it clear? So now you can try. Yes, Piyush. When you are multiplying two matrices, the number of multiplication required is the answer for your question, right? In case you drop a chat, drop a message, you'll get the answer also. So now is the question: the matrix multiplication required to find this A1 into A2 into A3 into A4. So what is this? The number of the dimension is 10 cross 5, 5 cross 20, 20 cross 10 and 10 cross 15. And you have seen for m cross n and n cross p, the number of multiplication required is mnp. Clear? This is what you have seen. So in the similar fashion, you need to find the minimum number of multiplication so that you can find the result. Now, you should also know that your objective here is to keep reducing the order of your matrix. Ultimately, you will get the same order of the result, but you have to keep reducing the order. Let's see. Like if you multiply these two matrices, what will be the next order of the matrix? It will be 10 into 20. Right? If you multiply these two matrices, the next matrix will be of 10 into 20. And what is the number of multiplication required? The number of multiplication required is 10 into 5 and 5 into 20. M into N, N into P. So that means 10 into 5 is 50 and then 20. So that will be around 1000. Right? Getting it? Whereas if you multiply A2 and A3 before, what will you get? 5 into 20 and 20 into 10. This will give you the dimension 5 into 10. So do you see that this dimension is bigger and this dimension is smaller? Right? How will it help? It will help us in the next operation, in the next multiplication. Right? So what is the number of multiplication required here? 5 into 20 and 20 into 10. 5 into 20 and 20 into 10. So that is going to be 5 into 20 and 20 into 10. Again, it will be 1000 only, right? So my suggestion is, let's do it like this. This A1, A2, A3, you will realize when you try other options. I'm leaving other options for you. So I'm writing A1 into A2, A3 and then into A4. Clear? So this is my suggestion and you can try other options also. So when you're doing A2 into A3, you can see A2 into A3. A2 into A3 is A2 A3 is 5 into 20 into 10. So that is 1000 number of multiplication required. And what will be the result of A2 A3? The order will be 5 cross 20. Right? So this makes it A1 into a matrix of 5 cross 20 into A4. What is the dimension of A4? A4 is 10 cross 5. So this make it 10 cross, I'm sorry, this is going to be 1 second. This is 10, okay. This is going to be 10. So this is also going to be 10. A1 into 5 cross 10. And what is the dimension of A4? A4 has a dimension of 10 cross 5. So 10 cross 5 will be. So what will be the number of multiplication required? It will be 5 into 10 into 5, which will be 250 multiplications required. The first one was 1000 multiplication, 250 multiplication, right? And what will be the result? You will get A1. What is the dimension of A1? A1 has a dimension of 10 cross 5. So it is 10 cross 5 into the result of this 5 cross 5 into 5 cross 5. So this will give you 10 into 5 into 5. So 10 into 5 into 5 is 250. So getting it, I'm numbering it. The first number is, let's see, this is your first operation, this one, for which you need 1000 operations, 1000 multiplication. Then you do second operation, this one. For this you get this much. And then the last one is third operation, for which you get this number of multiplication, right? That means ultimately you will get the matrix of 10 cross 5, isn't it? Of course you should get it. See this matrix. The last operation will give you 10 cross 5 size, which is very obvious. So that means the total number of multiplication is 1000 plus 250 and plus 250. So that is 1500 number of multiplication required. Clear? So that is 1500 number of multiplication required here. So that is option A. Clear? Now let's move back to the other concepts and then we'll see the questions related to that. So that was about the matrix multiplication. You can see that this basic Abhinav. Hi Abhinav. Mahela Saurav. Hi. So do you see that such a basic concept can make such a twisted and analytic question, right? So after this, we'll move to the other concepts, which is trace of the matrix. What is trace of a matrix? Trace of a matrix means that it has to be for the square matrix, first of all. It cannot be done for, we won't do it for rectangular matrix, we'll do it for square matrix. And by trace, we mean that sum of the diagonal elements. So that means A11 plus A22 plus A33 and so on. Clear? So for this matrix of order 3, -2, 1 and 9 are the diagonal elements. So the trace becomes -2 plus 1 plus 9 equal to 8. Right? What you have to do is add the diagonal elements. Add the diagonal elements. That's it. After that, let's see the properties. So the property says trace of A plus B is same as trace of A and trace of B, right? Whereas trace of AB is not equal to trace of A into trace of B, right? These 2 points should be seen together. Trace of A into B is all together, but trace of AB cannot be written as product of the trace. No. Also, whether it is A or A transpose, we'll see A transpose. What is A transpose? Let's see what is A transpose first. Transpose of a matrix means that you are interchanging the row with the columns. You are interchanging the rows with the column, right? Interchanging the rows with the column. So if you have 3 cross 2 matrix, that is 3 number of rows and 2 number of columns, it is interchanged and you have 2 number of columns now and 3 numbers of row. So it may be a rectangular matrix, but the result is if it is 2 cross 3, then the transpose gives you 3 cross 2. So rows and columns are interchanged. You see this 230 becomes the row 230. This column minus 145 becomes the column row minus 145. So rows and columns are interchanged. Right? Hello Mandar. Now, so now what you can see is property. So before that, let's get back to the properties of your trace of the matrix. Trace of the matrix says that the transpose of a matrix and the matrix all have the same trace. Why? Because when you transpose your square matrix, let's say this element, this element, this element, this element, let's say to this 2, 1, 3, 4. Now if you transpose it, what will you get? 2, 1, 3, 4. That means the diagonal elements are still at your same position. So if the diagonal elements are at the same position, the trace is 2 plus 4. The trace is also 2 plus 4. That means when you transpose it, you'll still get the same trace. Clear? Trace of AB is equal to trace of BA, and all these properties are also fine. You can see this. Now we were into transpose of a matrix. So transpose of matrix says when you transpose a matrix twice, you'll get the matrix same. That means you interchange the rows and column, and then you interchange the rows and column again. Okay? So if you interchange it twice, I gave you something, you gave me something. Then we exchange it again. You got what you had, I got what I had. Right? So the transpose done twice gives you the same matrix. Clear? Now, if you're trying to transpose sum, you can actually split it and sum of the transpose is also same. Whereas, see this, whereas transpose of the product changes the order. This is important. When you transpose the product, the distribution is product of the transpose in the reverse order. So if it is A, B, C, right, it is also written here. So if it is A, B, C transpose, it becomes C transpose into B transpose into A transpose. You're getting it? It has to be in the reverse order, right? What about diagonal matrix? Diagonal matrix is something which has only diagonal elements. Correct? Now if you transpose a diagonal matrix, the diagonal element will remain same and rest other elements are all 0. So no matter this 0 comes here, this 0 comes here, anything, it doesn't matter. So diagonal matrix and the transpose of it are all same. Hello Salman. So they are all same. Correct? Now so you have also seen that Aij is conjugate of a complex number. Z equal to, so is it visible? Is it live? Everyone? Yes. So now what is conjugate of a number? You know the conjugate of a number is simply negative of the complex part. So A minus IB. Correct? In the similar fashion, what you have to do is when you have to find the complex conjugate of a matrix, each and every element of the matrix should be conjugated. Correct? Each of the elements should be conjugated. Okay, Ayush, thanks. Thank you, Ayush. So 2 plus 3i conjugate will become 2 minus 3i. 4 being a real number, we all know that a real number cannot have any conjugate. Only the imaginary part is multiplied with minus. So this real part will give 4 only, whereas this I becomes minus I and 0 remains 0. So it is very simple. You have to conjugate each of the element of your matrix. That's it. Clear? Now, clear? So once you conjugate a matrix, what if you conjugate it twice? If you conjugate it twice, the real part remains same. The imaginary part is again multiplied with minus. So minus of minus becomes plus of IB, which is same. Correct? Which means that if you find the conjugate twice, you will get the matrix itself. You'll get the matrix itself. Now, what if the conjugate, let's see, what if the conjugate and the matrix are same? When is it possible? It is possible when the imaginary part is 0. Then only A becomes A, because B and minus B cannot be 0. It is only possible when B is equal to 0. So if the conjugate and the matrix are same, it has to be a real matrix. It has to be a real matrix. Then only the conjugate and the matrix can be same. Whereas if the matrix and its conjugate are negative of each other, like A and A are negative of each other, this is only possible when it is purely imaginary or 0. Right, Tiger? Good name. Okay. So what is transpose conjugate? Transpose conjugate means you have to transpose it also, you have to conjugate it also, right? And if you do it twice, so if you transpose twice, you get the same matrix. If you conjugate it twice, you get the same matrix. So this gives you same result. Whereas for these two cases, you can see the conjugate transpose, the order gets changed. This is important. What is it? For the complex case, now you should see for which of the cases the order changes. It changes for the transpose. The order gets reversed for conjugate complex, conjugate transpose, and it also changes for inverse. Right? So if AB transpose conjugate gives B conjugate into A conjugate. It is only conjugate for which the order remains same. It is only conjugate operation. See this for the this conjugate operation. For conjugate operation, the operation remains same. You don't have to, like AB conjugate is A conjugate into B conjugate. You don't have to change the order for this. Clear? So these are some of the other operations required: transpose, conjugate, complex conjugate, right? Some of the terms that this transpose conjugate may be denoted as A theta or A star or A transpose conjugate like this, or AH, because this is also known as Hermitian transpose. We'll see what is Hermitian transpose also, right? Whereas conjugate matrix is simply denoted as A conjugate, like A bar. Transpose is denoted as A transpose. Simple. So these are the terms how they are denoted. This is also denoted as A dash. It will be mentioned in your question when they are writing it like this, right? So let's see the classification, then we can again switch to the questions, right? This will be the last topic, classification of real and complex matrices both, and then we can switch to the questions. We'll see a couple of questions and then we'll move to the next session. So classification of real matrices. Classification of real matrices. What is real matrix? Real matrix means all the elements of the matrix are going to be real. It cannot be complex. It cannot be complex, right? There must be the referral code coming on your screen. It says that you will get some discount, right? So you can try applying that coupon also when you're purchasing the package. I'm telling you again now that more people are here. The package will have more than 450 hours of recorded lectures for all the subjects, and it will have around 20 mock tests, like entire subject, every subject. it will also have 100 numbers of subject tests, and then we can have live doubt lessons for all the subjects you are having, all the subjects of your branch, right? So go for the link, try open the web, check the details and everything, and apply the codes wherever you find, right? That's what we do these days, right? So let's see what is symmetric matrix. Symmetric matrix is something which has to be real. All the elements have to be real. Clear. Imaginary part has to be zero. Correct, Tiger? So you can clearly see. Now the symmetric means that the transpose of the matrix has to be same as the matrix itself. So once A12 is replaced with A21, both of them have to be same. Both of them are going to be same. So let's see this 2. Then now the diagonal elements don't get replaced. A11 remains A11, A22 remains A22, A33 remains A33. Good afternoon, Utkarsh. Utkarsh Tripathi. So you are from UP, huh? So the thing is, 2 minus 1 and 6 are going to be at the same position, whereas this 3, 3, 4, 4, 5, 5 are going to be replaced. A21 is replaced with A12 and A31 is replaced with A13. Of course, of course. So you are from instrumentation, right? Good. We have this question for all the branches. These are very basic and very very common questions for all the years, right? So it says symmetric matrices is something when you transpose, you get the same matrix. Check this. If you transpose this matrix, you will get this matrix, which is similar to what you already have, right? And for this case also, you can see these are some of the properties applied. What else? Any real matrix can be written as sum of the symmetric and skew symmetric matrix both. But before that, we should know what is skew symmetric. Skew symmetric means when you transpose the matrix, you get the negative of that, right? When you transpose the matrix, you get negative of that when you transpose, right? Check this. Now, we have already seen the diagonal elements remain at the same place. Hi, Charan Raj. Charan Raj, hi. So we have seen the diagonal elements remain at the same position. A11 remains at the same position, A22 remains at the same position. So how can it be negative of each itself? It is only possible when the number is 0. So that is important. For skew symmetric, the diagonal elements have to be 0. Clear? It has to be 0. Other than that, if it is A12 is 3, then A21 should be minus 3. You see this? 3 minus 3, 4 minus 4, 5 minus 5 and so on. Right? So any real square matrix can be written as these two forms. Right? For any real square matrix, if you sum A and A transpose, you will get the symmetric, whereas if you subtract, you will get skew symmetric. It is well written here, so I don't have to write it again. So skew symmetric gives you when you subtract it, and symmetric is when you add it. So this is what you can use to find it. Now the next one is orthogonal matrix. This is the last thing which we'll see, and then we can move to the questions. Very interesting questions we'll see. So orthogonal matrix is when the transpose of a matrix is equal to the inverse. We have seen that AB equal to identity means B is inverse of A. Now we are saying that A transpose should be equal to A inverse. That means A into A inverse is I, and instead of A inverse we can also write A into A transpose equal to I, right? So this is important. Is it clear? Good. So this is about the orthogonal matrix. Clear? Now we can move to the questions. We have 2-3 questions left, and then we'll see next. You can try this question. Try this question on yourself. I'm leaving it for you. Let's move to the next one. The question is the number of number of different n cross n symmetric matrices with each element being 0 or 1 where n is equal to 5. You'll also see very similar question in your recorded lecture. I have given you a recorded lecture question on this, symmetric and skew symmetric both. Pithoragarh. Okay. So Piyush, you are from Pithoragarh. Pithoragarh. I have been to Pithoragarh last year. I was there in Pithoragarh, and I have also been to Gopeshwar. I have been to Dehradun and other places, right? Haldwani, Almora. I have been to all these places. So last year I was there. If I'm right, this Airtel girl is from Pithoragarh. Please check, right? So the number of different n cross n symmetric matrices with each element being 0 or 1 where n is equal to 5. Let's see. Let's start with a small size matrix. Let's say we have a 3 cross 3. Then you will understand what I'm trying to say. 1, 2, 3, 1, 2, 3, and 1, 2, 3. So we have overall 9 elements. Now we know that for symmetric matrix, if this is 4, this has to be 4. If this is 5, this has to be 5. If this is 6, this has to be 6. Clear? Whereas the diagonal elements are independent to take any values, right? So if you know what is A12, A21, you cannot choose A21. You can only choose A21, right? You can only choose A21. If you have A2, so let's say A31. If you have A31, you cannot choose A13. It has to be same as A31 because it is a symmetric matrix, right? Whereas all the diagonal elements A11, A22, A33 can all be chosen independently. So this means for this 3 n equal to 3, this is order 3 matrix. I'm not going for 5 matrix. I'm just trying to explain it for the smaller size. So for n equal to 3, what are the number of diagonal elements you have? Diagonal elements, you have n number of diagonal elements. What is the total number of elements you have? Total element is n cross n. So out of n cross n, you have n diagonal elements which you can choose independently, correct? And after that, you are left with upper of diagonal elements and lower of diagonal elements. You getting it? Upper of and lower of diagonal elements. And they have to be same. A21 has to be same to A12 and likewise. So what are the elements left? Left elements, that is off diagonal element. What is the off diagonal elements? It is n cross n minus n. These are the off diagonal elements we have, and of which we can choose only half, right? Either we'll choose the upper half or we'll choose the lower half, or randomly, like if we are choosing A12, we cannot choose A21. Clear? So that means these are the number of elements we can choose independently. So what are the number of elements we can choose? We can choose n and we can choose this. Clear? That means this means overall you have n plus n into n minus n by 2, which is nothing but n into n plus 1 by 2. These are the number of independent items you can choose. Number of items or elements independently you can choose. Okay? Clear? So these are the number of elements you can choose independently. And so what if n is equal to 5? In our question, if n is equal to 5. So this is 5 into 5 plus 1, which is 6 by 2. So this is 15 number of elements we can choose independently, right? So talking about 5 cross 5 now. 5 cross 5. So what are the elements we can choose? 1, 2, 3, 4. Let's say these are all 5 elements. All the elements can be either 1 or 0. All the elements can be 1 or 0. 1 or 0. So that means all the elements can be chosen in two ways, either 1 or 0, 1 or 0. So that means we will have the first choice, let's say A11 two ways, then A12 two ways, and so on. Overall you have 2 into 2 into 2 up to 15 times. So this will be nothing but 2 to the power of 15 number of possible combinations. If any one of you are from electrical, you'll know that the digital concept of 0 and 1, and you can see that if you have 3 bits, you can make 8 combinations. That is 2 to the power of 3. So similarly, in this matrix arrangement, you are arranging all the elements at these places. So you can do it in 2 into 2 into 2 into up to 15 number of times. That is going to be 2 to the power of 15. Right? So this is going to be your answer, 2 to the power of 15. This is your answer. Beautifully designed. We have a very similar question on this on lecture, recorded lecture. You should visit, you should watch that video so that you'll have more varieties on this. Also, I have this question for you. Let's see if you can solve this. I'm giving you 2 minutes to solve this question. N minus 1. Sir, is not n minus 1 equations. We have n varieties. You go through this. I don't want to remove this question, so you just check it. It is n. The number of diagonal elements are n, and the remaining element is n into n minus n divided by 2. So please try it again. Tiger, please try it again. Yes, Tiger, correct. Hai? So we have n number of diagonal elements, n into n total elements, and then n into n minus n is the off diagonal elements, of which you are going to only choose half of it. So divided by 2. Clear? Please check it. So this is the question. It says we'll solve it in short. We won't take much time in this. It says A is a 5 cross 5 skew symmetric matrix, right? With entries in real. So if you see, we have already seen a 5 cross 5, be it any symmetric matrix. We have seen skew symmetric matrix has diagonal elements to be 0. So this A will have the diagonal elements to be 0. Right? Skew symmetric is where A is equal to minus of A transpose, and diagonal elements after transposed is at the same position, right? So that means you're going to have, it is n into n plus 1, n into n plus 1 divided by 2. So for A, skew symmetric, if it is skew symmetric, we need to have all the diagonal elements to be 0. And B is a matrix where the elements are given by Ij. What is Ij? This is n, if you remember the combinations, permutation and combination. So this is Icj, correct? Let's talk about the diagonal element again. Let's see, this is 1, 1, 2, 2, 3, 5, 5. This is 1, 1 position, 2, 2 position, 3, 3 position, 4, 4 position, and 5, 5 position. Anybody? Do you remember what is NCN? NCN is 1. What is NC0? That is also 1. What is NC1? That is n. What is NCN minus 1? That is n. So at this position, we are going to, I'm writing it here, you're going to have 1C1, then other one is 2C2, 3C3, 4C4, 5C5. So do you see that for this B matrix, you are going to get all the elements to be 1. This is going to be 1, this is going to be 1, this is 1, this is 1, and this is also 1. So all the elements, we'll get back to the last question again. So all the elements of, all the diagonal elements of B matrix is going to be 1, right? Because the elements are ICJ, combination, permutation and combination. Remember? So this is combination. If you are at 1 2 position, it is obviously it has to be less than that. So let's say 2 1, so 2C1 like that. So for 1C1, 2C1, 3C1 and so on, the diagonal elements are going to be 1C1, 2C2, 3C3, 4C4 and 5C5 and all are going to be same. So the diagonal element of A and diagonal element of B is ultimately going to be the diagonal element of C. Yes or no? So to find the trace, all you need is diagonal element of A and diagonal element of B. So what is it? It is going to be hi Vishwanath. So it is going to be 0 plus 0 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 and plus 1, which is overall going to be 5. Which is overall going to be 5. So that means the trace of C. For trace of C, we only need the diagonal elements, and that is why I am focusing on the diagonal elements of A and B. Why? Because for this C matrix, A and B are at the diagonal position. So this 5 cross 5, this 5 cross 5 will make the diagonal elements of C, which is 10 cross 10. So this in sequence, and after this it will continue from here like this, right? This is overall going to be the 10 diagonal elements, which is 0 0 0 0 0 1 1 1 1 1 1, and finally we'll have the trace as sum of all, which is 5. Clear? So this is the answer of this question. So the trace is going to be 5. One last question, very quick, 1 minute, and that's all. Right? The last question is orthogonal matrix. Very quick, very quick. It's like less than 1 minute if you want. It says A is a orthogonal matrix, which means A into A transpose. So that means A transpose should be equal to A inverse. Yes, orthogonal matrix says that A transpose is A inverse. We need to find A into A transpose. So A into A transpose is nothing but A into A inverse now, because it is orthogonal, and we know that A into A inverse will give you identity matrix. Although we haven't seen inverse, but we have seen some of the basic properties. That inverse of identity matrix is the matrix itself. Correct? Is the matrix itself. Now, what is the order of A matrix? It is order 4. So the result is also going to be order 4. So do you see that C is going to be the answer? Fourth order identity matrix. Fourth order identity matrix is going to be the answer for this question. This is your GATE question. I don't remember the year, but 1 marks question. It's like you see it, you find the catch. I mean, these analytic questions, you need to find the catch. What is the catch? Until unless you know these properties, you cannot solve it. If you don't know the property, what will you do? You'll find the transpose conventionally. Then you'll multiply A with A transpose. Then you'll get something. Then you will do the inverse. And then you will get the answer. So that will be like 5 minutes gone for 1 marks question. Whereas if you know the property, you can solve it just by looking. You don't have to pick the pen. That's it, done. Within 1 minute, like 30 seconds. Right? So this is important. When you are approaching GATE, apart from knowing the concept, apart from knowing the formula, you have to have analytic understanding of this subject, right? Be it maths or any other subject, any other subjects, right? So this is very important. Clear? So with this, we'll wind up. Today what we learned is all the basics of matrices, and we had a really good and interesting session. Vishwanath, hi, thanks. 4 cross 4 is the right answer. So I really enjoyed it with you people, and I don't remember the year. If you go with all the previous year question, you'll get the answer. You'll find it. So in the next session, we are going to take over the interesting topics like determinant, inverse of the matrix, rank, and simultaneous equations and all. So put a thumbs up on the video, share with your friends, right? Share with your other friends so that we can learn together, we can have a competitive environment, we can like have more energy, right? And we'll continue the next session. Obviously, you'll know when and where to meet me again. Which year question? Okay. So thanks everyone. We'll wind up here. Okay.